All right, we come to the applications of Newton's second law of motion. In the first lesson in this video series, I've shown you that F, which is the resultant force according to Newton's second law of motion, is given by the product of the mass and the acceleration of a body. Okay, so F equals ma. And I told you that this F represents or can be interpreted as a resultant force, the resultant of two forces. It could be called the net force or resultant force. You can call it the accelerating force or the decelerating force. So I'm going to show you in this video how to apply this equation, in different instances. I'm going to start with the kinetics of motion along a straight line or the dynamics of motion along a straight line. Now you have a mass m acted upon by two forces P, and this force P is the force that is accelerating or pulling the body in this direction. We can also call, if it's the case of a car, we can call that the driving force, the force produced by the engine of the car. And here we have the resistive force, the force that opposes motion, Fr. Now let me first of all start with a case where the two forces act in the same direction. Probably you have the body of mass acted upon by two forces. Let's call them F1 and F2. Now, since the two forces act in the same direction, their resultant is just the sum of F1 and F2, and that equals mass times acceleration according to Newton's second law of motion. But here we're looking at the case where the body is acting. Here we're looking at the case where the force acts in different directions, and we can call this force F the frictional force that opposes motion. Where the surfaces are smooth, that is, there's little or no frictional force, Fr is 0, or the coefficient of frictional force, that's static or dynamic, is 0. It means that force P is the only force acting on this body of mass m, and that is given by Newton's second law of mass times acceleration. So if force P is given, let's say force P is 10 Newton, that's the pull that is acting on the body, and then the mass of the body is given as 2 kilograms. It means that the acceleration produced by force P is given by P over m. That gives us 10 over 2, which is 5 meters per second square. So that gives the acceleration of the body when there's little or no frictional force acting between the two surfaces. Now let's see case 2 where there's frictional force acting. Suppose frictional force F is not 0, then the resultant force F acting on this block is the difference between the force P, which is pulling the body in the direction of motion. That's the force that is exerted on the body to give it this direction, or to give it the motion in this direction, minus Fr, which is the frictional force. Now, this is the resultant of the two forces, which is given by Fa according to Newton's second law. So, from this equation, we can see that F equals the difference between force P and force Fr, which is the frictional force. F is also equal to mass times acceleration, or we can say that P minus F is equal to P minus Fr is equal to ma. You see that now? So it depends on what you are given. That will tell how to apply this equation. Let's look at some cases. Let's say case 1. You are told that a force P of 50 Newton is applied to move the block in this direction, and the frictional force opposing motion is 20 Newton. If the mass of the block is 2 kg, calculate the acceleration that is produced by this by the resultant force. Calculate the value of the acceleration A. So in this case, you see that we're giving force P and force Fr, which is the frictional force and the mass. We use these two sides of the equation. That is P minus Fr is equal to ma. My force P is 50 minus 20. Mass is 2 times acceleration. That gives me 30 equals 2a. My acceleration, therefore, equals 15 meters per second square, which means this block accelerates at the rate of 15 meters per second square. And if the block starts from rest, they may ask you to calculate the velocity attained by this body maybe after 5 seconds. After 5 seconds, we use v is equal to u plus at. You can see that we can go from dynamics of motion to kinematics. Okay, so if the body starts from rest, then the speed attained after 5 seconds will be 15 times 5, which means the body attains a speed of 75 meters per second if it continues with a constant acceleration of 15 meters per second after 5 seconds. Then sometimes you may be given case 2 or case 3. You are given that a force of 20 Newton is applied to the block of mass m, as you can see in this diagram. Now, this force produces an acceleration. The force produces an acceleration of, let's say, 2 meters per second squared on the block of mass 2 kg. Now, they may ask you to calculate the resultant force on this block. What's the resultant force? Calculate, number one, the net force, or can call that the resultant force, or can call that the accelerating force. What is the net force? Suppose a force P produces an acceleration of 2 meters per second squared on a block of mass. Given that there's frictional force acting, the frictional force is not negligible. What is the net force? That's number one. Then number two, calculate the frictional force opposing motion. Frictional force that opposes the motion of this body. So we write again the equation: resultant force is equal to mass times acceleration. That gives us a 2 times 2. That gives me 4 Newton. So the resultant force acting is 4 Newton. Now, how do we calculate the frictional force acting? We'll come again by writing the forward force, the pull on the body, minus the frictional force Fr is equal to mass times acceleration for Newton's second law of motion. Now they have told us that P is 20, so 20 minus Fr equals to, have calculated our MA as 4. That gives me a frictional force of 20 minus 4. That is, if you make that the subject of the equation, it gives you 20 minus 4, which is 16 Newton. So that gives a frictional force acting of 16 Newton. How about in the case whereby you are told that the frictional force acting on this body, let's say a car of mass 500 kilogram, is produced or is given an acceleration of 6 meters per second squared. And then if the frictional force of 800 Newton acts on the body, the question we want you to calculate the driving force, the force that is produced by the engine of the car. Calculate the force produced by the car's engine. What's the force produced by the car's engine if this is given to you? You are told that the mass of the car is 500 kg, and that car is given an acceleration of 6 meters per second squared. A frictional force of 800 Newton act on the body. What is the force produced by the engine of the car? So we come in here now. We have force. The mass is given as 500 kg. So we use the formula P, which is the driving force, minus frictional force equals mass times acceleration, which means I'm looking for force P, which is the force that is produced by the engine of the car. That force P gives me MA. If I take minus Fr to this side, it becomes plus Fr. My M is the mass of the car, which is 500 times 6, plus the frictional force, which is 800. That gives me 3,000 plus 800. I'm going to have a force of 3,800 Newton. So you can see that giving you this kind of situation, the mass of the car is given, and then the engine produces an acceleration of 6, and that's also giving the frictional force of 800 Newton. Calculate the force produced by the engine of the car as the driving force. That gives a total of 3,800 Newton. Now again, suppose you are told that a force of 500 Newton produces a constant velocity of 20 meters per second. That is, if you are told that a force of 500 Newton acting on a car from the car's engine gives rise to a constant velocity of 20 meters per second. Now here you can see that if the velocity is constant, then it means that the acceleration of the body is 0. When the body moves a constant velocity, it has no acceleration. So which means the resultant force acting on the car is 0. If resultant force is 0, therefore means that F, which is the driving force minus the frictional force, is equal to 0, because resultant force is M, which is 0. It means that the driving force in this case is equal to what? The frictional force. So when the body is in motion, and that car, for instance, or vehicle is moving at a constant speed, whatever the driving force is, it is the same as the frictional force opposing motion. So they may want to want to check if you know this, want to test you on this principle, whether you know that when a body moves at a constant speed, the driving force equals the frictional force. Since the resultant force is zero, the acceleration is zero, it means that the driving force P is equal to the frictional force. Okay, how about some cases where you are given or you are asked to calculate the coefficient of friction between two surfaces? Coefficient of friction between two surfaces. How do you go about that? Now, in that case, we have P minus Fr, which is your resultant force, is equal to mass times acceleration. If the coefficient of friction is given instead, we have two types of frictional force. We have the static frictional force and the dynamic frictional force. And we have P minus Fr is equal to M. You can decide to choose this side of the equation, these two terms. And the frictional force has been defined as the product of the coefficient of friction and a normal reaction that is on a plane surface. The normal reaction of a body on a plane surface is given by the weight of the body, or is equal to the weight of the body m times g. So that gives you frictional force Fr equals mu times m times g. So substituting this equation, I'm going to have, for instance, P minus mu mg is equal to mass times acceleration. This is used when the coefficient of friction is given instead of the direct frictional force. Or sometimes we also calculate the frictional force acting on the body, given the coefficient of friction and other parameters in this equation. Take, for instance, we are told that a force P of 10 Newton moves a body along a horizontal surface, a rough horizontal surface of coefficient of friction 0.1. The coefficient of friction has no unit. And taking G as 10 and the mass of the body also is given by, let's say, 5 kg. Want to calculate the number one, let's calculate the accelerating force, the resultant force, the net force on this body. What's the net force? It can be called the net force, the resultant force, or the accelerating force. So what's the net force on this body in this situation? So the net force F is equal to mass times acceleration, and since we are not given the acceleration here, we are going to use the difference between the two forces. That is, the net force also equal to the forward force and the frictional force Fr. And we can calculate frictional force here because we're already given the coefficient of friction, which is 0.1, times the mass of the body, which is 5, that is using this equation, times the value of acceleration into gravity, which is 10, roughly. So that gives you 5 Newton. That is the frictional force acting on the body. So that the resultant force F is now P minus Fr. My P is 10 minus 5. That gives me 5 Newton and the resultant force. So resultant force is 5 Newton. And then that same resultant force is given by the product of mass and acceleration according to Newton's second law of motion. So that gives me acceleration as 5 over the mass of the body, which is 5. That produces an acceleration of 1 meter per second squared. Or sometimes we even asked to calculate the force P. Force P is equal to ma from this same equation plus mu mg. So if the mass of the body is given, let's say 5 kg, the acceleration produced is 2 plus the coefficient of friction is 0.2, the mass is 5 times 10. What is the force that is necessary or needed to move the body in the forward direction in this case? So we come here and say P equals, this is 10 plus 0.2 times 10 times 5, that gives me 10. So force P equals 20 Newton. So this is how we apply the dynamics of motion, that is Newton's second law of motion, to the motion of a body along a straight line, including when there is frictional force acting and when there is no frictional force acting.